Probability and permutation. Example: 6 jokes about books from Groucho Marx, Bob Blitzer, Stephen Wright, Henry Youngman, Jerry Seinfeld, and Phyllis Diller are each written on one of 6 cards. The cards are placed in a hat and drawn one at a time. What is the probability that the man's joke will be delivered first and the woman's joke last? So here's the keywords that we have to note here. So man's joke will be delivered first, and then woman joke would be delivered last. And what would be the woman here on the different books? So let's circle this. So this is a woman, and we have a man here, Stephen is a man, Henry is a man, and Jerry is a man. So we have only one woman here. Okay, so to solve this, since we have 6, so that's another thing that we have to note, and it's drawn one at a time. Okay, so there's no repetition. So using our fundamental counting principle, let's start with 6, and then the next one would be 5, since we used up already one joke, and it continues until you have 1. And multiplying those numbers, so 6 times 5 times 4 times 3 times 2 times 1, it's 720. So that's 720 permutations or ways to arrange those jokes there. And then what's next would be, what is the probability that a man joke will be delivered first and woman's joke last? So let's take care of the last phrase. It says man's joke will be delivered first and woman's joke last. So there are 6 of them. So 5. If you're going to count this, let me have the man author here. 1. This is 2. This is 3 here. We have 4. We have 5. So there are 5 of them. Okay, so let's start with the first joke. That should be 5. 5 men, because we have to get the man's joke first. So man 5. We used up 1 already, so it gives you 4. So it should be descending. 5, 4, 3 times 2 times 1. So that's the 5th joke. And the last one would be a woman, which is only 1. And then we will multiply that. So 5 times 4 times 3 times 2 times 1 and times 1. It gives us 120. And then let's write the probability. If we're going to have man first and then woman last. So that would be 120 That's the permutation or number of ways that we can arrange if we have the first joke with a man, and then the last one would be a woman, divided by 720. That's for the arrangement for 6 jokes. And then that would be the probability. And then we just have to reduce that by dividing 120. You can also express your answer into a decimal value. So without reducing it, our answer would be 120 divided by 120 is 1. And then 720 divided by 120, that would be 6. So that should be 1 over 6. So that would be the answer here. Okay, you can express that into a decimal value also. 1 divided by 6, it gives you 0.17. So you can have that also, 0.17 as your probability, or 17%. So that's the answer for the first example. Okay. So next would be probability and combinations. This is winning the lottery. Powerball is a multi-state lottery played in most U.S. states. It is the first lottery game to randomly draw numbers from 2 drums. The game is set up so that each player chooses 5 different numbers. So let's take note about the number 5. Different numbers from 1 to 59. And 1 Powerball number from 1 to 35. Twice per week, 5 white balls are drawn randomly from a drum with 59 white balls numbered 1 to 59. Then 1 red Powerball is drawn randomly from a drum with 35 red balls. So we have 59 white balls here and 59 also from another drum, white balls. And then you have the Powerball drawn randomly with 35 red balls, numbered 1 to 35. A player wins the jackpot by matching all 5 numbers from the white balls in any order. Okay, so note that we have 5 numbers and matching the number on the red Powerball with one $2 Powerball ticket. What is the probability of winning the jackpot? So we're looking at the probability of winning the jackpot prize. Okay, so because the order of the 5 numbers shown on the white balls does not matter, this is a situation involving combination. So we will use combination here. We begin with the formula for the probability. So we have the probability for winning. It's equal to the number of ways of winning over total number of possible combinations. So this is total number of possible combinations. Okay, so let's have the 59 combination with 5. So because we have to select only 5 among the 59. Okay, so we can use our calculator to calculate that. So press 59, math button, go to PRB, choose 3, and then press 5 and hit enter. So the combination would be 5,006,386 ways to arrange that with the 5 numbers among the 59 balls there. Next, we must determine the number of ways of selecting the red Powerball because there are 35 red Powerballs in the second drum. There are 35 possible combinations of the numbers. So we have to multiply this by 35 because we have 35 red Powerballs for the second drum. Okay, so multiplying this by 35. Okay, it will give us now times 35. 175,223,510. Again, it's 175,223,510 ways to arrange that. And then since you're looking at the probability for winning, so we need to, you have only one, right? Ticket to do that. Number of ways of winning, you have only one. So we apply that. So having this formula here, we have only one that we can apply. And that would be probability of winning now would be equal to 1 over 175 million 223,510. Again, 1 over 175 million 223,510. So that would be the probability of winning. Okay, you can always change that into a decimal value if you want to, but this one could be our final answer already. Okay, so that's the two examples using the fundamentals of counting principle, combinations, and permutations.